Hey guys, welcome back. This side Sahil. Hope you are doing great. And in this small tutorial, we will try to understand how the cable sizing is done when cable is manufactured and used for the utility. The cable is common. You can use in your household to the industry. Everywhere for the flow of the power, cables or conductor are used. Okay. So how their sizing is done? To understand the meaning of the sizing for a particular feeder, for a particular capacity of the current carry, which kind of the cable I have to use, and what kind of the SQM of the cable should be there, that it can work seamlessly and without disturbing the system. That's the agenda of this. So when we talk about the cable side, so there are few recommendations from the IS end that equals to, if I talk about, okay, and just to set fan, and I have to use the fan with, just give me a few seconds. Okay. So if, if I talk about the cable side, so there are two standards. One is one is IS 3961. I have to follow. This IS basically tell us the recommended current ratings for the cables, and this is especially for the LT cables and HT cables up to the 33 kV system. And there is another IS which I have to follow. The IS number for that is the IS 3961. This is part 6 and this is the part 7. Okay, these two are very crucial for the uh, cable sizing, because these IS code tell us, for example, there is a 240 SQM cable. Okay, how much current it will carry? Okay, what is the conductor copper and the aluminum? That is the double standard XLP or PVC. So basically, this is the very important thing that these IS code tell us. Okay, so we will discuss these IS code in the later part. Right now, I will focus on the how the cable sizing is done. So first, there are three things for the cable sizings. That point number one that I have to use, the derating of the cable, derating of cable ampacity. Okay, what do you understand by the derating of the cable ampacity? For example, there is the 400 SQM cable, and suppose that this carry the current of 400 amps. Okay, and this is the aluminium conductor, and 3 core is the cable. Okay, this is the basic detail that will be provided by the manufacturer. Okay, to understand this, uh, Okay, the content is disappeared. I just rewrite it again. Okay, so I guess I already discussed. We will discuss in the later slides. Okay, so when there is the current for the cable, so there is heating, and this heating is not good for the current ampacity. If there is more heating, so cable ampacity degraded. Why? Because we have to ensure that smooth power flow. If the higher amount of the current is going and there is a heating happening in the cable, so definitely this will deteriorate the life of the cable. So there is the more heating, that's the ampacity should decrease so that it can be balanced. Okay. For example, I tell 400 SQM. It's designed for 400 amps. Okay. Now, if I put this cable in such a condition that there is a more heating, okay, so I have to reduce this ampacity. So that there is air circulation is less because heating is more, so temperature rising. So can reduce the ampacity of this cable so that the both the effect nullify. The cable can run smoothly. Okay, I am laying this cable in the air. So if there is the air, so circulation of the air and heat is disappeared in the system. So there is no adiabatic. Okay, the energy is constant. Okay, and if I lay this cable in the duct, so there is no circulations. So I have to reduce the ampacity of the cable. So basically, some kind of the factor are defined in the system for this particular purpose. Okay, I will tell the name of these factor. These factor is due to the soil thermal resistivity. The laying method. What is my laying method? And it may be the underground. So I start pressing. So derating of cable. Okay, first factor is uh, laying method. This is the physical parameter basically that derate or increase the cable ampacity. For example, if you are laying the cable in underground area or in duct, so in the both the cases, in the all three cases, the ampacity of the cable is reduced. Second thing is, okay, if we are laying our cable in such a starter, there is that starter provide the cooling of the cable. So in that case, the cable ampacity will increase. But if starter is not able to provide the cooling the cable, so definitely the ampacity is came in the picture, so that the effect of the temperature and cooling will be nullified to each other by reducing the ampacity of the cable. Okay, so these are the factors which is very crucial for the derating of the cable. And one more factor is that, okay, for examples, if we are running the more runs of the cables, okay, this is the one cable, this is the another cable, okay, so these cable cumulatively generate more heat. So this will also affect to increase the temperature. To nullify that, we have to reduce the ampacity. So if I speak in the very layman word, The ampacity is the design ampacity of the cable in the ideal condition. If we deviate from the ideal conditions, there may be the some kind of an increase in the temperature of the cable. So this will deteriorate the life of the cable. For running that, for operating that cable in a particular design life cycle, we have to take the considering the derating ampacity of the cable factors. So that's totally depends upon the laying of the nature, in which strata we are laying the cables, and how many parallel runs we are laying the cable. So if I define this factor is the K1, this factor is the K2, and this factor equals to K3. These all factors cumulatively, if I say K effective या K equivalent, that will be the multiplication of the K1, K2, K3 and Kn. So this is totally depends upon the physical parameters or in a particular environment in which we are laying the cables. Hope guys you understand this concept. ठीक है. So one is the de-ampacity of the cable. So keep in your mind, if a cable is ampacity is the 400 SQ cable have the 400 amps ampacity. So it's not necessary that it will carry the 400 amperes in a particular environmental conditions. It may increase the ampacity or it can decrease the ampacity, but as my experience, there is the higher chances to decrease the ampacity of the cable. Only one particular condition, the ampacity can be increased where the arrangement or physical environment is supporting the cooling, more cooling of the cable than heat producing by the cable. Okay, so this is the fundamental things that happen with the ampacity. Okay, now coming to the second thing which I have to convey with you, that equals to ISC. ISC, short circuit current rating of the system. Okay, so obviously मैं मेरी जो केबल है, I am using this particular cable in a particular segment of the power system. Basically it's supporting the flow of the power. Okay, so I have to keep the thing that obviously wherever I applying this cable, so there is a chances of the short circuit. Okay, so if I am applying this cable to be between these two buses, okay, so it will withstand the short circuit of this system. Okay, for example, my system short circuit is the for 25 kilo ampere for 3 seconds. Okay, and so for the smooth and reliable operations, whatever I am using the power cable to connecting these two buses should able to withstand this 25 kilo ampere for 3 seconds. Okay, so there is a one formula to calculating ISC. What is the short circuit current of the system? That equals to ISC equals to KA by root T. Okay, this is the particular formula we use to define the ISC of the system. Okay, there is, what is the ISC? ISC is nothing but that equals to system short circuit current. Okay, and what equals to K? That equals to constant K and A area. A is the area. What is this? CS, cross section area of the cable. Okay, and time, for which time you have to sustain this system, and the K, value of K is different for the aluminium conductor and the copper conductor. Okay, so this is the very precious formula you have to keep in your mind that what equals to ISC. ISC is nothing but we have known this ISC for a particular system. For to calculate area equals to I multiply root T upon K equals to area. So this is the minimum area of the cable. Area means cross section area. That means SQMM of the cable. Okay, we have to keep in the mind. Okay, and the values of K are different. If you refer IS code, so there is a mention the values of K. It's around 0.143 for aluminum and 0.93 is for copper, and we will I will show you these calculation with a live example. Okay, these two things have been completed. Okay, so two things we have defined. What is the ampacity of the cables, and what is the minimum cross section area of the cable is required. Okay, now okay, now try to understand the basic fundamental how the power flow. Okay, so for example, from bus number A to bus number B in a power system, when I talk about the bus, so these are the junctions. Okay, from this junction to this junction I have to carry, for example, 1250 amps. Okay, that's clear. For example, the short circuit for this system equals to 25 kilo ampere. Okay, so if I define the aluminium cable, so aluminium ISC equals to Ka by root T. Okay, IS is short circuit, K constant for aluminium, the copper is different, and A equals to SQM of the cable, and root T equals to the time for which the short circuit capability of the current can be withstand. Okay, so for example, this value comes 260 SQM. By using this, if I calculate A, and this will come 260 SQM. So the whatever the cable I have to select, that should be greater than equal to 260. ओके, जो भी मैं सेलेक्ट करूंगा केबल का जो एसक्यूएम होगा, दैट शुड बी हायर साइड ऑफ दिस. ओके, you understand the purpose of the minimum SQM, because this SQM is required to withstand this fault. If you go on the lower side, your system can run smoothly. But if I talk about a worst case scenario when the fault comes in the system and the system have to carry this 25 kilo ampere current, then your cable will not able to withstand this. There is some kind of this leakage or blast can occur in this particular cables, and you have to replace this cable with a new cables. Then again the capex cost. So this is not a reliable power system we are talking. So that's why this is required. Okay. To first and very most criteria. Okay. Second thing, we have to clarity that we have to use the higher capacity of the 260. So we cannot use the 240 SQM. We can go for the 300, 400, 500 SQM cables. Okay. So I choose 300 SQM cable. In the cable manufacturer or IS code we refer, because every SQM is not available. We have to the range 242. We jump for 300 SQM. Right? Okay, say 300 SQM cable have for rating of 350. I am just assuming for aluminium conductor. Okay, 350 I am assuming. Okay, I have to 350 is ampacities of this cable. But if I consider the K factor, and if I go K equivalent, okay. So for example, my K equivalent equals to 0.8. So I multiply 350 divided by 0.8. So it will came in the picture 280 amps. Okay, 280 amps. So what will happen? One of my conductor is able to carry 280 amps. Okay, so I have to use multiple runs. What was my requirement? My requirement was 1250 that should be carried by 280. I cancel and it go around 5 runs. Okay, so I have to carry the 5 runs of the cable. That's clear from my side. Okay, now all the things are happen, but we have to check one important things, and that important thing is associated with the voltage drop. When I talk about a voltage drop, basically equals to the loss of the cable. Okay, the efficiency of the cable we talk, because the cable have some kind of the resistance R plus JX. Okay, why I am mentioning the R plus JX equals to Z equivalent of the cable. Okay, there is some resistance and there is some reactance plus capacitance, the concept. Okay, the OEM and the IS code both provide the R plus JX values. How these came in the pictures? Simple. There is the conductor, so there is a resistance. Okay, the some kind of the minimum value have the resistance and the reactance. Why this is come in the pictures? Because in the transmission line or conductors there is a mutual inductance and the mutual capacitance came in the pictures. For this particular regions there is the reactance came in the pictures. For detail you have to refer the power system, how the reactance and the capacitance compare in the TL lines or in the cables. Okay, here we will not discuss about that. So there is the voltage drop, and voltage drop that equals to system losses. Since voltage का drop and the system का losses, okay, resistance is there, to there is system loss. We have to design a system such a way that my losses should come in the minimum way. Okay, so that should be very minimum. Okay, to consider that we have to calculate the voltage drop, the percentage voltage drop, and to calculate this percentage voltage drop I have to uh, have a one formula, how it's calculated. Okay, so for this there is a particular formula that equals to root 3 into the current rating into R cos phi plus J sin phi into X, Jx sin phi. And what is the cable length? I have to multiply with this the cable length, and further it's multiplied by the 100, and this whole system is divided by the line voltage. What is the my line voltage and what is the number of parallel runs? Parallel runs into 1000. Okay, we will have a one particular dedicated formula for this. So root 3 into ampacity, total ampacity that should be carried current. Okay, full load current, that should be the full load current we have to consider. And R cos phi plus Jx sin phi into cable length into 100 divided by the line voltage into number of runs into thousands. By calculating this, we have to consider the voltage drop. Okay, so what I have to keep in the mind how much my voltage drop should be. Okay, so if I talk about the Indian contact, Indian con, mm, so the voltage drop is keep in the mind 3 to 5%, and there is a hack you have to consider in mind. For example, this is the my power system and this is the my generating system. Okay, and there is generating system, there is a step up transformer and the TL lines, again TL lines, again TL lines. This is the my end customer. Okay, so there are different cables because voltage level is same. Maybe I put a transformer here and maybe I put transformer here and here. So in every segment there is the different voltage. Okay, so the cable will be different. Okay, so if you use this 3 to 5% here, 3 to 5% here, 3 to 5% here, the community go from 9 to 20, around 20%. Okay, so this is not acceptable, boss. Okay, but what is the meaning of 3 to 5% end to end from generation to this point? There should be not 3 to 5% loss. Okay, so for example, if here I talk about the distribution system, that in the LV system I can go 0.3% loss is acceptable. For this HV side, if I take 0.1 to 0.2% loss is acceptable. It's totally depend upon the how much your transmission lines and what the particular cables you are using this. Okay guys, hope you understand these fundamentals, how we are calculate the cable sizing. Okay, and the second part of this video will be released soon, where I will show you a practical example for a particular power system where we calculate the short circuit current. Okay, since I will provide this data and we will learn how to calculate the short circuit ratings or currents for a particular system. This is a different part, but when I provide the ISC value, length of the cable or any length of circuit, and we will define how much of runs of the cables required and which SQM I have to use. These things we will elaborate in a detailed Excel sheet with real life example. Hope guys you enjoy this video, have some smile on your face and happy learning.